You are tuned to Iri-e-learning and I am your host, Teacher. For this lesson on mixtures and separation, we will examine pure and impure substances. Check the description box for links to all the videos associated with this unit. By the end of this lesson, you should be able to distinguish between pure and impure substances, define the term mixture, list examples of mixtures, state the characteristics of mixtures, state the effect of impurities on boiling and freezing points. First, we will examine pure and impure substances. Pure substances consist of only one substance, which can be either an element or a compound. Now, a compound such as sodium chloride is pure because it consists of sodium chloride particles or crystals only. That is, no other substance is mixed in with the sodium chloride crystals. We can also consider a sample of copper pellets, and each pellet within the sample is a pure substance because it's made up of only one type of atom, which is the copper atom. Then we can consider the entire sample with all the copper pellets, which also is considered to be pure because no other substance is mixed in with the copper pellets. Next, we have a pure sample of wheat, and it is pure because it consists of only wheat grains. On the other hand, impure substances are mixed in any proportion with other substances but are not chemically combined. Previously, we saw that compounds and elements are pure substances. However, if these compounds or elements are mixed with other substances, then the sample becomes impure. So taking our sodium chloride, for example, if it's mixed in with other salts and dirt, then that sample of sodium chloride becomes impure. Also note that these substances are not chemically combined with the sodium chloride, they're only physically mixed in. Now, if the pure sample of copper pellets is mixed in with, say, some tiny plastic beads, or it could be another element, or even with a compound, the sample of copper becomes an impure sample of copper. Similarly, the wheat sample becomes impure when another substance, such as these green glass beads, which have been added or mixed in with the sample. So you may have noticed that all the examples we have used for an impure substance, there's a common verb, and that is to mix. So there's always some other substance that is physically mixed in. So therefore, note that impure substances are mixtures. We can now explore mixtures since we can distinguish between pure and impure substances. Therefore, what is a mixture? The definition states that a mixture is formed when different substances are combined physically, not chemically, in any ratio or proportion. As a result, mixtures are impure substances. Examples of mixtures include air, and air is a mixture of different gases: nitrogen, oxygen, carbon dioxide, and other gases such as argon, water vapor. And note that nitrogen is the most abundant gas in the mix. It's about 78%. Seawater is a mixture of mineral salts, water, and sand, and the mineral salts are often dissolved in the water. Dirty water is also a mixture. It's a mixture of soil and water. A fruit salad is a mixture of different fruits. In this particular case, we have mixed pineapple, strawberry, tangerine, grapes, and kiwi. Next, we will state the characteristics of mixtures. For this section, we will highlight 5 characteristics of mixtures. The first characteristic: mixtures have no fixed composition. That is, all the substances can be mixed in any proportion. When mixtures are formed, energy is neither produced nor given off. Mixtures retain the properties of their components. Mixtures have no fixed melting or boiling point, and this is the case because they are impure substances. We will actually review this shortly, but you can also check out the video on the heating curve by looking in the description box for the link to this video. And the final characteristic: components of mixtures can be separated by physical means. So, how do impurities affect the boiling and freezing points of a liquid? The effect of an impurity on boiling point, using water, the universal solvent, as the example, we know that pure water boils at 100 degrees Celsius. However, if another substance is dissolved in or mixed with the water, it becomes impure. As a result, the impure sample of water boils at a temperature higher than 100 degrees Celsius. Therefore, impure liquids boil at a higher temperature than the pure liquid. The effect of impurity on freezing point. We know that pure water freezes at 100 degrees Celsius. However, an impure sample freezes at temperatures below 0 degrees Celsius. And this would be evident when freezing seawater, which contains dissolved mineral salts. Therefore, the freezing point of impure liquids is lower than the pure liquid. Here are the lesson summary points. A pure substance is made up of one substance, whether an element or a compound. An impure substance has two or more substances physically mixed in any ratio or proportion. A mixture is formed when different substances are combined physically in any ratio. Impure substances are mixtures. Air, seawater, and sand with water are examples of mixtures. Mixtures retain the properties of their components. Energy is neither produced nor evolved when mixtures are formed. Components of mixtures can be separated by physical means. Impurities increase the boiling point of substances, but decrease the freezing and melting points. So it's quiz time, and you have 5 seconds to answer each question after it is read aloud. Question 1. All of the following are pure substances except A. Distilled water, B. Aluminium, C. Seawater, D. Copper. The answer is seawater. Question 2. Which statement is incorrect about pure substances? A. Pure substances can be elements. B. Pure substances can be compounds. C. Pure substances are mixed with other substances. D. Pure substances are never mixed with other substances. The answer is C. Pure substances are mixed with other substances. Question 3. All of the following statements are characteristics of mixtures except A. The components of mixtures cannot be separated. B. Mixtures have no fixed melting or boiling point. C. Mixtures retain the properties of their components. D. Energy is neither used or produced when mixtures are formed. The exception is A. The components of mixtures cannot be separated. Question 4. Identify the option that accurately gives an example of a compound and a mixture. First, I'll list the compound followed by the name of the mixture for each option. A. Sodium chloride, calcium. B. Seawater, air. C. Sodium chloride, air. D. Calcium, sodium chloride. The answer is C. Sodium chloride is a compound and air is a mixture of different gases. Question 5. How does an impurity affect the boiling point of water? A. An impure sample of water boils at a temperature below 0 degrees Celsius. B. An impure sample of water boils at a temperature below 100 degrees Celsius. C. An impure sample of water boils at the same temperature as a pure sample of water. D. An impure sample of water boils at a temperature higher than 100 degrees Celsius. And the answer is an impure sample of water boils at a temperature higher than 100 degrees Celsius. We have reached the end of our lesson. If you found this video helpful, remember to like, share, and subscribe. When you subscribe, you will receive notifications as new videos are uploaded. So until next time, I am Teacher with Iri-e-learning.